Welcome to episode 287 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing okay. I guess we should talk a little bit about the awful weather that's going on right now. Like half of Texas lost power, I think. It's very scary. Hopefully they get that resolved soon. How are you doing in Colorado?
Oh, I mean, we've had winter weather, but it's Colorado.
You're used to it.
We had winter weather, yeah. Like oh, no, there's some snow on the ground and it's cold. I mean, we were cold. We were -8 Fahrenheit, -23 C.
Wow.
And then when I looked at one point, I actually saw a reading of -13 Fahrenheit, which I think was something like -30 Celsius, but it didn't set any records.
Right.
I mean, it was cold for a few days. Yeah.
I didn't get anything. We've just been getting rain over and over. Yeah.
Oh, well, I mean, on the upside, from our perspective, a little bit of snow got our river valley here. Our winter snow totals are almost up to normal finally, which have been below normal. And it's really important for the farmers out here. It's like a big deal.
Okay. Well, at the top of every episode, I like to read a piece of feedback. This week, I actually got a message from Abigail Martinson on LinkedIn. She connected to me and wrote, I started listening to CppCast last year to help as I talk to C++ engineers for work, and I now look forward to listening each week. As a recruiter, I know how most engineers view me, so I think it's important to become as knowledgeable as possible, and your podcast has played a huge part in that. I just thought that was really cool that programmers are listening to the podcast and making use out of it. I know, I haven't been recruited in a while, but if a recruiter reached out to me and knew their stuff with C++, I would probably be a bit more responsive and when talking to them.
Doesn't your boss listen to the podcast?
Maybe. Not sure if he still does. I'm not looking to get recruited right now, but I mean, yeah, if I was looking for a new job and the recruiter I was working with, knew their stuff with C++, I think that'd be pretty cool.
Yeah. I mean, if you don't get must have 5 years experience with C++ 17 kind of, requirements or something like that, then that's handy.
And I know I do hate it when I get those out of the blue emails we're looking for someone with all this experience in JavaScript or something like that I don't even use. But
right.
Yeah. So thought that was cool. We'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Carl Cook. Carl has a PhD in computer science from the University of Canterbury, New Zealand. Since graduating in 2005, he has worked mainly within finance, ranging from hedge funds and market makers through to cryptocurrency trading. Carl is interested in high performance and low latency systems and enjoys the competitive and challenging nature of trading. As a hobby, he enjoys recreational flying and sees parallels between the safety built into aviation and the safety in place within regulated financial markets. Carl, welcome to the show.
Thank you very much. Good to be here.
So you mean flying actual airplanes, right?
Yeah. Although at the moment with COVID, it's just on Flight Simulator, but yeah, I want to get a chance. Actual airplanes.
Well, that's interesting. I mean, in all seriousness, why would COVID limit your ability to rent a plane and go flying?
There are curfews in the Netherlands, for example. There are curfews on but you can exercise and recreate during the day if you want. But also, it's not an entirely nice experience with face masks and things like that right now. It just takes the fun out of it a little bit.
Okay.
Well, Carl, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about your work and high-frequency trading, okay? All right, so this first one is a blog post about Khronos releasing SYCL 2020 for C++ heterogeneous parallel programming. And I think we talked about this release when it was still upcoming with Michael Wong a couple months ago, right, Jason?
That sounds believable.
Yeah. So I'm not sure, how much to go into detail on this, but if you want to hear about what's in this release, you can probably go back to that episode or read into this blog post. Is there anything you wanted to highlight here, Jason?
Well, I do find it interesting that they jumped 2019 version numbers, because they went from 1.2.x to 2020. But in all seriousness, I've actually been looking at SYCL lately, and it's been on my to-do list for like years to actually play with some of this GPU programming stuff. And I think this is, for me, it looks like this would be the gateway drug here, because it is cross-platform.
Right.
And that's what I would want for the kinds of things that I do. But I haven't actually tried it yet.
Is that possibly in an upcoming C++ Weekly episode?
Yes, but at this rate, it'll be in like 18 months. What about you, Carl? Do you use any of these higher level abstractions for GPU programming?
Not directly. We do a small amount of GPU programming at work, but I'm fairly well detached from that side of things. I'm very much, I think, the same as you. I'm just watching this sort of from the sidelines at the moment. And when I get a rainy afternoon or a rainy week one day, I might dive in a little bit deeper.
I looked at the programming model and I'm like, I'm just going to give this a try this afternoon. And then I looked at the programming model and I'm like, I'm going to do it next week. What is it called? The one that NVIDIA is working on that is more like you can just call C++ 17 parallel algorithms directly. That is just this afternoon, I'll play with it. But I don't have an NVIDIA GPU on a computer that I have a C++ compiler on. Like I do have an NVIDIA GPU, but it's in the system I use for gaming and such. It's got like different purpose for me. And besides, that's running Windows.
STUDPAR, that's what it was called, right?
Yeah, so that's limited to Linux with an NVIDIA GPU, which is not a combination I have direct access to at the moment.
Right.
Yeah.
Okay, next thing we have is a post on the Visual C++ blog, and this one is Visual Studio Code C++ extension cross-compilation IntelliSense configurations. And this is pretty neat. They keep adding more and more to the C++ support in Visual Studio Code. What this post is about is if you're doing cross-compilation, so you're on a Mac and you're targeting Linux, for one example, then instead of all the IntelliSense being based on your kind of what it perceives as a default Mac environment, it'll actually look, you're using a Linux compiler, then it's going to give you Linux-based IntelliSense. So that's pretty neat.
Yeah.
Yeah. Do you make use of Visual Studio Code, or what is your IDE of choice, Carl?
Yeah, that's a religious war right then and there, right? Let's go. I personally, I used to use Visual Studio many years ago, and I know a lot of people who use Visual Studio for C++. Most of my coworkers are actually using Qt Creator. Find just awesome. And saying that, VS Code is definitely turning up in large numbers now. Most of our new starters seem to gravitate towards it for some reason. And I haven't seen anything particularly wrong with it. It seems to be doing the job quite well. Typically, compilation is actually done off on Linux servers somewhere with just using your Windows desktop to run code, and it seems to work pretty well.
You mentioned new developers seem to be gravitating towards it. I wonder if it's becoming popular in university amongst engineers in training.
That's a good question. I mean, I suspect when new developers turn up and they look at it and they go, "Oh, what am I going to do? I finally get a chance to start from scratch here. Do I really want to be building up a massive, VIRC or something like that? Maybe this is a chance where they try something new and shiny." And people seem to get started with it pretty quickly, and they don't stop using it once they've got it set up. So, yeah, I'm relatively positive about it.
Okay, that's an interesting point, because I do recall one of my earlier jobs before I had really set myself in my ways to become an old man set in my ways. I was like, I'm starting a shiny new job, and I tried kdevelop at the time and used it for a while until I ended up moving to Vim, actually, which I think we talked about kdevelop briefly a couple of times on the show.
Yeah.
Which could be seen as a predecessor in a way to Qt Creator, I guess, maybe.
I mean, don't get me wrong, I have VI key bindings in Qt. So I just try to take the best of everything I can, and it works all right.
Yeah. But yeah, and now I use CLion for most of my development with the VI bindings enabled.
Yeah.
Is that an option in VS Code? I'd imagine it probably is.
It's an option everywhere. It's an option in Compiler Explorer if you really want to.
I do know at work a lot of people do use CLion because I see the Java processes being spawned all over the dev servers.
It can be a bit of a problem if you have a very large C++ project, as it consumes all available memory.
Yeah, it seems to consume all available CPUs as well.
It's getting better. Yes. It's definitely getting better.
Okay, and then the last thing we have is this is a post on QuantLab Financials GitHub, and I don't know how long ago they started this, but they're doing these C++ tip of the weeks and modern C++ tip of the weeks, and I think it's one of our previous guests who is working on these, right, Jason?
It's two of our previous guests, actually. If you look at Lenny Majorani and Chris Jusiak, we've had both on the show in the past. Yeah.
Yeah, so it looks like they're up to 213 tips. I'm sure there are plenty of really good ones in here. Did you look through any of the recent ones, Jason?
I started to click around, and then I got distracted by something else at the moment. You know how it goes, but I was looking at... No, I didn't dig into any of them. Although I do notice now that you say something that it says episode or whatever 213, but only goes back to 182. I don't know if they're pruning older ones or what. Or if they only just started making this thing public in the last 6 months. That's not immediately clear to me. There's 52 commits to the repository.
That is a good point. I doubt they would just prune them.
Well, but GitHub gets sad once you have several hundred files in a directory.
Right.
I work on projects that break GitHub. You can't open certain folders on GitHub. Not a deal.
Yeah, I'm curious about that now. Maybe we should ping him on Chris or Lenny on Twitter and find out what the answer is to that. Okay. All right. Well, Carl, do you want to start off by just telling us a little bit about the work you do at Optiver and how C++ factors into that?
Yeah, sure. So I work within the sort of the core auto trading team within Optiver Amsterdam. So my team develops all of the auto traders that we trade on, goodness, probably about 30 or 40 exchanges around the world. Optivera has probably about 5 or 6 offices, including an office in Chicago, an office in London, office in Sydney, office in Beijing. But we tend to trade actually across from a single office. We'll trade, for example, the Dutch office will happily trade in the US markets as well, in the South American markets. So about half the job is working with the exchanges and writing code to actually function within the exchanges to be buying and selling financial instruments. And probably the other half of the job is just working on the algorithms, the actual trading strategies behind effectively what we use to decide when we buy, when we sell. That would be a pretty simple description. Basically everything is in C++ from within my team, and the vast majority of my office would be C++. A little bit of Python here and there, a little bit of C# for some of the user interfaces, but then again, a lot of the interfaces, user interfaces, are in C++ as well.
Now, this is not at all C++ related, but when you said that you're happy to trade in whatever markets you can from wherever the office happens to be, and maybe you can't speak to this at all, but it kind of sounds like Optiver would end up competing against themselves if different offices are trading in the same exchanges.
Yeah, to some degree we do, because they're separate trading entities, and that's fine. So I should qualify this by the vast majority of our work that we do is what we call market making, which is effectively printing what we're willing to buy and what we're willing to sell for. So it's passive, and we're there on the exchange, basically providing the liquidity to the market. You'll find the market makers are actually the companies behind the vast majority of people willing to list or print their prices to the exchange. And so, yeah, indeed, sometimes we will end up improving on another office's prices. I mean, there isn't a lot of overlap, but there is some, and it does happen sometimes. Then it's actually quite interesting to see who ultimately has the better trading strategy.
Interesting.
Yeah. So what are some of the unique challenges about programming for low latency trading that cause your whole team to work in almost entirely C++?
Yeah. So the Dutch office has been around for about 35 years. We've been writing our own auto trading systems for at least 15 years. So it's quite a big office. There's a lot of existing systems, a lot of integration points, a lot of components, a lot of moving parts, quite a complex sort of risk and assurance set of systems in there as well. We started with C++ and basically never looked back in that respect. And what's happened recently within the last few years is we've actually made even more of a conscious decision to write more and more of what we can in C++, because for us, it actually really works quite nicely. And so we have our own, networking libraries that for communication within the office, within the different components, that it works really well. And we have a nice sort of client server architecture. We have nice protocol serialization and deserialization libraries, sort of our own inbuilt reflection and things like that. The more that we, I should just say it another way, we just kind of realized that we've got everything we need here, and so more and more we throw away components written in other languages and just have a very quite simple C++ stack for most things, I should say.
It does seem sometimes that a problem is easier to express in a different language for whatever reason, like maybe a functional programming paradigm or something. Yep. Well, I mean, we can do that in C++. So do you have any strategies at all for when it's, do you like embed scripting languages into C++ or anything like that? Do you know what I'm trying to say?
Yeah, it's a good question. We've definitely gone down that route a few times. The traders at present do have a scripting language that they can use, which then gets converted into C++ for us. I'm not even sure what the current incarnation is, but we did use Lua for quite some time. But again, that all basically gets converted back into, it gets parsed and processed by our backend servers, which are all C++. Look, I mean, for sure, there's like functional languages can be really nice for certain problems. So I guess the exception here is that the vast majority of our research code would probably be Python.
Okay.
Because of course you've got all of the goodies, all of the numerical goodies, and all of the graphing, all of these cool things that you can do, such as this, real-time analysis with Juniper notebooks and just, the really nice number handling libraries. In saying that, all of our models for predicting, for effectively generating prices or generating other sort of mathematical attributes of shares, they're all in C++, and we just put Python bindings over everything. So whenever there's a sort of a need to do something, either like get access to something that's written in C++, or to get the performance of C++, we just write it in C++, put a Python binding on top of it, and then that makes it accessible to everyone else as well.
Kind of the same approach that a lot of AI research has gone, I believe.
That's interesting.
A lot of the neural network libraries, I believe, are written similarly. We talked to someone about that at some point.
Yeah, that sounds right to me.
Yeah. I mean, we used to try to have a dual implementation, so we might have we did have Python implementations of different pricing models and things, but they just get too hard to maintain two different copies. You get mathematical inaccuracies, and it's two code bases. You're better off with one.
Right. Makes sense.
Yeah. So one thing we haven't asked yet is, are you able to keep up with the latest standards? Are you using C++ 17 currently, or are you already looking at C++ 20?
Yeah, it's an interesting one. So we don't get much benefit at all out of using the latest, greatest compilers.
Okay.
Or the latest, greatest language features. In fact, to a degree, we tend to just stand back a little bit and make sure that things are stable. So that's pretty important for us. The other thing, not that stability is an issue. It's not like there's problems where early versions of the compilers just have terrible implementations. That's not the case at all. What we do find is a challenge is to keep our code really clean, keep our architecture clean, keep the code consistent, keep it understandable, keep it readable. And it's a real challenge within trading, because things change very, very quickly. And something you could be working on today, you might have to wrap that up tomorrow. A new opportunity might come along. There's a potential that, hey, we're not going to use this strategy anymore as of next week. That one goes. And so there's a huge churn and turnover, a huge number of commits, quite a lot of people working on basically the same things. So we have to be very, very careful not to, for example, go, hey, coroutines are awesome. Let's just put coroutines into a quarter of our code base and see how that works out. And we have to be very, very careful in that respect.
Okay. I'm curious about what exactly these strategies look like that you're constantly rewriting and then possibly abandoning, one week after another. What are these? Can you describe these a little bit more, maybe?
I'm just trying to think of it.
Detail.
No, that's fine. I'm just trying to actually think of an example to back up what I'm saying now. An example might be potentially a market that we thought was really interesting, or we thought that a potential, like a possible new sector on a market was really interesting. We start trading there. It turns out that we were wrong. We just didn't have the numbers right. And so that would be a market where we might go, right, we're not going to trade there anymore, or not for the meantime. Another example, could just simply be a strategy that we thought would be profitable. It turns out that we were trading a lot, but the trades weren't profitable in the long run. And that could be anything from an implementation error, which you can fix, to just fundamentally we got our numbers wrong. In that case, we'd walk away from that strategy. And markets change. Markets change all the time, so you've got to keep up with that.
So does the C++ code in any way itself adapt to these market changes? Like, do you use profile guided optimization or something like that to help tune your code?
Yeah. So that's a good question. We do use profile guided optimization a little bit, or we have in the past a little bit. Generally, we're not too sensitive to those sorts of market changes.
Okay.
So it's kind of two parts to your question, really. No, we generally just write a one-size-fits-all sort of fundamental system that should be able to trade on most markets, and we sometimes have to bend the architecture for special cases, or we have to take a step back and refactor and have a look and go, you know what, we didn't quite model this right. Let's do this again and properly in the next iteration now that we know a little bit more. So that's kind of answering how well does our code work just as markets change. Answering the question about profile guided optimization, We haven't had a huge amount of success with that. Other trading companies might have. But the problem that we find, it's a pretty classic problem. It's just one of basically overfitting the model. And so we can get, an auto trader or an auto quoter absolutely flying for a day's replayed data. So if we ever get that day again with exactly the same trading events, we're going to be pretty damn quick. Unfortunately, the 99.9% of the time where that day doesn't happen to be replayed, it's slower.
Yeah, if you knew the day was going to be replayed, you would do all kinds of things differently, I would think, not just need to do them faster.
Yeah. So that's the trade-off that we have is we want to be fast. That's important. If you're not within a reasonable balance of performance, you're not really in the game at all.
Right.
But also on the days where you do get strange behavior, so a very, very busy trading day, like a day that no one saw coming, or something else that really the markets are really, really very hot, you also need to be able to handle that. And so there's always that tension there. Because if you push it too much, you'll probably find that on a day with a huge amount of volume, you're out of the market, which is not what you want. In fact, with Optiver and any other registered market maker, you can't be out of the market. There's regulatory obligations to be in the market, to be trading for the entire time that market is open to trading.
Oh, interesting. Otherwise, you risk getting fined or something.
Yeah. So well, indeed, or kicked off the market because well, the markets need. It's a symbiotic relationship. The markets or the exchanges need the market makers to provide the prices, and you need to provide the prices all the time. Like say with a couple of weeks ago with GameStop, that caused a lot of volatility in the market. It'd be quite easy to just turn off the systems, and walk away and go, hey, like this week is just too hard for us. There's too much craziness going around. But that's exactly the time that the exchanges need the market makers to be there, to just be providing a bit of stability to as much of the market as they can.
Right.
Interesting. One thing I was curious about is you mentioned there being a lot of churn of new commits coming in all the time. Do you have a lot of good practices in place to handle that? Are you code reviewing every single commit going in? I kind of imagine you must be. Make sure that someone's not going to bring down the whole trading network.
Yeah. So from a regulatory point of view, and in the last 5 to 7 years, the regulation has just increased, threefold. It's been a heck of a lot more regulation in the US markets, but actually pretty much all around the world. So you need to be able to prove that your systems are in control at all times. You need to be able to prove that you've done a prudent amount of testing for any release of any software that goes near the exchange, which makes sense because it has happened a couple of times where participants and exchanges have had code that hasn't worked and it has caused material damage to the markets. It's caused spikes in stocks. It's caused, flash crashes a couple of times. So you absolutely need to prove that, that you're not going to have a system that's going to do that to the exchange.
What does this proof look like? Like, do you have a large set of unit test suites or integration test or like higher level, like?
Yeah, so there's guidance on this from the regulators, but for us, we absolutely have like a huge amount of unit tests, but we record every run of unit tests. We record the output of those unit tests that gets committed. We record any log files that were produced. We record what the output was versus the expected output, and that's actually code reviewed. So those commits are code reviewed, and those commits are committed as well.
Does someone review those? No, sorry.
And then we have a suite of automated tests as well, which takes an hour or two to run just to make sure that there's been no regressions as well.
Interesting. Hour 2 would be considered a very long test suite by some people's standards.
Yeah. To be honest, I could make a change in the morning and have that running in the exchanges in the afternoon.
Okay.
As long as I can get other people to review what I've done, both the actual code changes and the review of the testing that's been done as well. There'd be a few eyebrows raised if I did want to get something into production that quickly. But it's actually not too bad. I mean, one, we have to do it from a regulatory point of view, but two, it's kind of nice being able to sleep easy at night as well, not knowing that, gee, tomorrow I wonder if that code's going to work all right or not. So it's kind of there's a natural sort of motivation to making sure that things are pretty well covered.
Have you gotten the 3 a.m. the Japanese market is probably a problem phone call that you have to go deal with?
Not with Optiver, but I have with other companies I've worked for. To be honest, though, it's a pretty the financial system's pretty amazing in that respect. All trades that we do we have internal processes to make sure that our orders and trades look correct. We've got a huge amount of risk checking around that, and just sort of monetary checking around that as well. But then there's external parties looking at this all the time as well. So the exchanges are looking at it. But for every trade and every order that we send, actually, a copy of that gets sent to an external company that's running a whole bunch of analytics and machine learning on it as well, just to make sure that everything's going okay.
I don't want to derail too much from the technical discussion, but one thing you said a moment ago interested me when you talked about all this regulation going into changes you're making in the software, and how that regulation has become, I guess, more strict over the past few years.
Mm-hmm.
And you mentioned the GameStop thing, and I thought one of the things that was being said in the news was that there was really a lack of regulation, and that there were hedge funds buying like 50% more of the shorts than should have been available. And I was just kind of curious about that.
Yep. So we've definitely derailed the technical side. Okay, that's fine. I can handle that. Yeah. So, I mean, the markets are very heavily regulated. I can only short sell as much as the market allows. And there's actually a very well thought of sort of layered system of protection here. So when you buy shares, it's not you buying shares directly from the exchange. It's you buying them from a broker that ultimately will go to a clearer, which will ultimately go to the exchange. And so if, for example, something went really wrong, the worst case scenario probably is that the broker fails. I think once in history, maybe a clearinghouse has failed. It would never pull down an exchange with something like this. So I'm not entirely sure where the accusations of breaking regulations come from, because if there are regulations that have been broken, that'll be investigated. I don't know. I can't imagine a scenario where people either selling a huge amount of GameStop or buying a huge amount of GameStop actually is a regulatory breach.
I'm not sure. I just remember hearing that stat that 150% of the shorts that should have been available were bought.
It does seem okay. So being able
we can move on though. It's okay.
Well, I'll say one thing. Being able to sell one unit of stock that you don't own is somewhat hard to understand. So I just say it's even more harder to understand how you can sell more than 100% of the stock that you don't own. So yeah, short selling is a very interesting thorny debate that's been going on ever since markets were invented.
I know. I'm just curious if Rob got in on that GameStop bubble.
No, I mean, I heard about it after it was all happening. Kind of wish I had, but no, I was not in any of that.
No, I looked at that and I said, yeah, well, okay, whatever. Maybe back to the technical a little bit. I want to maybe just clarify something, because you're talking about how all of the Optiver offices are independent, and you're talking about you're at Optiver, an exclusive, almost exclusive C++ shop. I'm just curious, is the C++ code that you work on shared across the offices, or do the offices? Okay.
Yeah, it's a great question. No, we don't. We tried that. It didn't work so well.
Interesting.
Really?
So we, are you guys serious about the interesting, or was that a sarcastic?
No, I'm a
little surprised that an international company doing the same work in all your different offices wouldn't have a shared code base. Yeah.
But I mean, compared to like Google with their mono repo that has 400 billion lines of code that everyone works on, it's like the evil opposite.
Yeah. So, boy, we've tried it a few times, and I still wake up in sweats at nighttime, sometimes thinking about it. So, Git wasn't around when we first started doing this, so that's the first point I'd like to make.
Okay. Using CVS or?
Yeah, we're using Subversion.
Okay, that's better. But
but it's very difficult because, sure. So some core libraries, and we have a lot of really core libraries. They were sort of shared for a while because we gave up on sharing strategies and the sort of high level things. It just got a little bit too difficult because the market traded out of Sydney is often very, very different from a European market, for example. Okay. Just completely different regulations and just different logic, even if it's relatively the same style of trading. It just got too hard. We just spent all of our time resolving merge conflicts and fighting bugs that came out of resolved merge conflicts because didn't merge them correctly. That's quite hard to spot sometimes. So our very, very sort of lowest level libraries, so the event model that we have, the logging, the interprocess communication, shared memory, those sorts of things, that was shared for a while, and that just got too hard as well. And so we eventually went, no, we're just running our own fork of the repo per office. Amsterdam and Sydney have roughly the same code base, more or less, or a fork of the same code base. Like that look relatively similar, I think. The US office is basically purely C. That's sort of the direction they've gone in now as well.
Interesting. That is interesting. I'm not just saying it.
So I think the argument there is that there are complexities with C++. You have to be really disciplined when the code is moving around so much. And in the US, I've just found that actually C seems to be enough for them, and they're pretty happy with that choice. Within Amsterdam, there's probably no way we'd do that. We're very much in the C++ camp.
Do you ever get like a call or a Slack message from another office? Hey, Carl, you won't believe we just made this change. It had a huge impact. You guys need to reconsider this part of the code or something like that?
Yeah, so that does happen because the idea sharing is there for sure. Yeah. But it is interesting because if you have, 4 or 5 different offices all trying to solve the same problem pretty much independently, it's kind of like one of these genetic algorithms, right? Like the best one wins. And then the information is shared around. So, for sure, the information sharing is there, but it's not done via code. It's done more at the sort of face-to-face level.
It's interesting. Effectively having the teams compete against each other to see who's got not really directly, but
yeah. I mean, I use the word compete. It's a little bit of a possibly a stronger word than reality.
Right.
But yeah, it's by no mistake that we have this model.
Okay.
But just with the amount of code changes we make, particularly across the offices, I would not like to go back to the days of global repo. And that's with a relatively low number of developers. I mean, I don't know the exact numbers, but I'd be guessing around about an average of 50 to 100 developers per office.
Okay. Can you give us an idea approximately how large your code base is?
Our one, we're not entirely sure because I ran some numbers the other day, and it's actually a little bit hard because where are all the repos within Git? we have a lot of different repos. We think somewhere between 1 million lines of code to 5 million. That's pretty wide.
Yeah,
That's a wide range.
Big, but not gigantic.
Yeah, and that's for my office. I think the other offices would be broadly about the same.
Sure.
And then our applications are, I just ran some basic word counts, line counts over them, seem to be about 250,000 lines of code for an auto trader or for a thing that does this, on the market. About 10 to 20,000 lines of code is actually custom code for that auto trader or auto quota or whatever it is. The remaining 190,000 lines is common libraries that we use to build up. It's the base for our applications. And of those common libraries, I'm guessing somewhere between, we only use about 10 to 20% of those per application. So this was just a sort of a shotgun approach of getting some lines of code metrics.
Okay.
And then another thing is we build from source every time. There's no concept of headers and libraries. We just literally with Git bring everything in, CMake it, build it, grab a coffee, grab another coffee, come back.
I'm guessing if you're in the Amsterdam office, you have one of those nice fully automated espresso machines as well, which I tend to use in the Netherlands.
We actually have a in-house barista.
Oh, that's even better. I've only been to 3 offices that had an in-house barista. Yeah.
Okay. Yeah, although the office is in lockdown right now, so we all got sent a coffee machine to home. Yeah, that'll do.
Did they really send you a coffee machine?
For a Christmas gift, yeah. Which it's been getting some serious use.
That's cool. Kind of funny.
Yeah. I also learned that making good coffee is difficult.
Yeah.
So I know we asked earlier if you're, on the latest version of C++, and you said you're not necessarily on the latest and greatest. Is there anything you're looking for from C++ that you would like to be standardized to make the type of work you do easier?
Yeah, for sure. So one of the reasons we're not on the latest and greatest is we tend to be pretty conservative with our servers. So we typically run a pretty mature version of, Enterprise Red Hat or CentOS or whatever it happens to be. So we use their dev toolset. So we're currently on GCC 8 with the option to run GCC 9 if we want. I still suspect, I haven't checked, but I still suspect things like small string optimization are not in there with the patched version of GCC that we use. I could be wrong, but
the copy on write change, binary compatibility. You might have to stupid ABIs.
Yeah. So we're a little like we don't take GCC 10 for example, just because they're not the cards that we've been dealt, and that's actually fine. We use a few features of 20 that we use at the moment. We use most new features that are available on the compiler. 23 is interesting with the bitcast. We were talking about that today actually at work. We have a few potential issues with alignment, and we're like, oh, how are we actually going to fix this? And it's like, oh, what do you know? It's in 23, problem solved. So that's kind of cool. Coroutines is something I do want to look at more, because our code is with lambdas. Lambdas were awesome for us. Like lambdas just cleaned up our code base. We could just go, hey, here, I'm going to call something. I don't want to know when you're ready, but when you are ready, well, I don't care how long it takes, but when you are ready, I'm going to pass you, this lambda to execute. You can pass a standard function, but lambda, same thing. So our code really got cleaned up for a while, but unfortunately, then we've kind of pushed lambdas a little bit too far. We have a lambda which creates another lambda.
That's fine.
So Yeah, but it
You
goes
can't really go far. It's fine. Yeah, use as lambdas as much as you want to.
So, I mean, you have to scroll right on your screen quite a long way to actually figure out when you're done. And so it's just the way that we program. We program in this asynchronous kind of style. We have no blocking calls. That would be a nightmare, right? So we always just do work until we can't anymore, give that to something else to deal with, and then we do work where we can. And this is the way our event call works. We just, spin whenever there's something to do, we do it. If there's no event coming in, then we just spin again until an event comes in, like a new price arrives in the market, and we need to, figure out what to do with that.
It's like you've written your task scheduler.
Yeah. Oh, look, everyone does. Or you can use ASIO. I've used ASIO in the past, and that was fine using its event engine or whatever they call it. I can't remember now.
Since I've used it also.
Actually, I've been impressed with ASIO for event-based programming, except for a couple of weird bugs around timers, which bite you in lifetime, but we'll just park that for now. So yeah, we have a handwritten event model, and I'm sure all trading companies do, because you just want to know exactly what's going to happen all the time. You don't want the event model to all of a sudden be doing a memory cleanup or some house cleaning tasks. But the more and more I look at our code, the more I think that in a perfect world, I think coroutines could actually make our code a bit easier to read, a bit simpler.
If you end up deploying coroutines and have a huge success with it, then you have to come back on and explain to us what you did.
And if it's a massive failure,
then come back on and explain to us why.
Good story. Yeah, and it'd be something that we'd have to do quite slow as well. Like, we'd have to be quite careful about it. It'd have to be pretty careful to make sure that we don't get caught out by object lifetimes or allocation where we weren't expecting it. Also, the ability to debug as well would actually come into it as well a little bit. So this would be more sort of trial and error with a small project and just see how it goes. But I wouldn't be overly surprised if in a year or two from now we are all about coroutines. We'll see. But the other thing that I think is missing, and I haven't been looking too much at the proposals, but shared memory communication, interprocess communication. It'd be awesome to have that as standardized support.
I don't know if there's anything like that in the pipeline, though there's still discussion about transactional memory, which is tangentially related, I think. But
so there's the Boost interprocess library as well, which we use a little bit, but we've just found that we've hand-coded the majority of what we need, which is just effectively fast shared memory messaging from process to process on the same box. I know other trading companies are doing this because I've got friends in other companies. Everyone's doing this.
Right.
Everyone's hand coding it. Everyone's having the same mistakes. In fact, in your previous podcast, I forget his name, but he was working on the PowerPoint plugins. He was
also doing his own shared memory kind of work. Yeah,
those unmapping files and what happens if another process with different user permissions use that same file name and crashed uncleanly and the kernel didn't clean it up, and then you start up and you can't map the file name that you've picked because Linux isn't going to let you lock that file. And these problems are solved, but it's interesting that everyone has to solve them themselves.
Right.
Just out of curiosity, what does it look like to debug on this software? Do you have some type of mock trading system that you're able to work with in order to actually test your code?
Are you talking about testing in particular, or are you talking about
debugging testing? Yeah.
So the exchanges will offer test exchanges with varying degrees of quality. Some exchanges are excellent. Some exchanges are bordering on non-existent. So that's obviously a little bit of a concern. But there are certainly test exchanges that you can test on. The problem is generating the exact sequence of responses that you want. Some exchanges are great and they have really good automated support for doing that, or semi-automated support. Other exchanges, you have to try to simulate your own sequence of events, such as putting in an order on a stock that hopefully no one else in the test exchange is also trying to test on at that point in time, then send in an imposing order for maybe only half the volume, see if that trades, see what happens to the rest of the order. That's not a huge amount of fun. So to a degree, we have exchange simulators to just simulate what we expect the exchange to be doing. Obviously, that has a little bit of risk as well. Exchanges, however, when you do a software update, such as using a new protocol of the exchange, so they might upgrade their API, they typically have a certification process as well. So we sit there with the exchange on the phone, go through all of the likely scenarios, and they tick it off to make sure that they're seeing what they expect to at their end.
Okay.
For actual debugging, say for example, we had an issue, typically we'll just crash out and restart again. We try to not recover from errors that shouldn't be happening. That typically means that there's a bug. And so when I say we restart, often we don't automatically restart, but often we'll roll back just to the last known stable version. Something happens, we've got a quarter, we've got the symbols in there. It's just trying to work out what's happening. But a huge amount of real-time metrics is going on as well. So, typically we'll catch something before it really goes bad. If there's excess memory consumption or excess allocations or excess messages between us and the exchange, that'll be flagged pretty quickly.
That's really interesting. I'm familiar with systems that, obviously like a watchdog or something, or if there's a crash, then they just come right back up again. But the idea of not just coming right back up again, but, having available and easy to access the last known binary or whatever that you could roll back to.
Yeah, and look, it's all in Git.
Right.
All of our configuration is done through Git. So if we want to upgrade, it's a code review, pull request. And then that'll automatically, once that's been approved, that's triggered to upgrade in production. And so if we need to roll back, it's very simple to figure out how to do that.
Interesting.
Although we are looking at, this is an idea that Sydney have, which is quite cool, is actually just return values on when we exit to indicate if definitely don't restart, do restart, but not until, this component has been fixed. Or, there's 255 values we can use there to indicate what has happened, and so that's quite a nice way of semi-automating recovery after shutdown.
Yeah, and you could take it a step further, more than just the byte, as if you could somehow manage to what's the word I'm looking for, like touch a file real quick or something that is even more information.
Yeah. Dependency ordering is also a fun one too, because we have nearly 15,000 components running in production every day, or 15,000 running processes. And we have to start them up in the right order. And we've got a degree of automation there to do it automatically. But of course, it gets a little bit difficult sometimes, particularly if you're communicating over a shared message bus and it's not entirely sure if this other component is up yet or not. So yeah, sometimes it can be a little bit of fun in the morning if something goes down, to then figure out exactly the correct sequence to bring things back up again.
Right. Sorry, bringing back flashbacks of systems that I worked on that had a very theoretically, we could reboot the whole system at once, but in reality, we didn't rely on a DHCP server, so each device got its own link local address, and, well, I won't go into details, but they would all come up with the same link local address. So in that particular environment, it would sometimes take like 3 hours for the system to finish rebooting as they all negotiated what link local address they were going to use. Anyhow.
Okay, well, I think we're starting to run a little low on time. Carl, is there anything else you wanted to talk about before we let you go today?
Not really, actually. It's been fun. I'm just having a look through some notes there. Not really. I think the main thing I want to sum up, I guess, is that, I mean, for us, C++ has been awesome. The hard bit is just managing it, picking and choosing the right language features. It's certainly challenging to keep code that's constantly changing, readable and bug-free. I think our modern C++ has been great for that, just to be able to auto out all of the, iterative declarations. And, we can write some really nice code these days. But I think that's actually where the challenge is, when you've got big systems that are constantly changing and it's just, that's where the challenge is. It's just trying to keep the code sane. But yeah, so far so good, actually. That's my summary of my life at the moment, I guess.
Well, and since I've been, or one of us has been asking pretty much every guest that we've had on lately, it sounds like ABI compatibility not a big deal for you. You would be happy if C++ broke ABI.
As long as the world doesn't end. I'd have to think about it quite carefully from what happens to our servers. Are we actually relying on a library that we didn't realize about? But if we can't do it, given that we compile everything from source, we have literally no libraries except for glibc and the usual suspects.
Right.
Yeah, if we can't do it, no one can do it, because really we have the simplest ABI constraints. We have none. We compile from source.
Right. Well, so far, Rob, I don't think we've had a single guest who has said that breaking ABI would break their system. So
sure, and I think we would all agree with Carl that we're good with it as long as it doesn't cause the world to end. No one wants to cause the world to end with an ABI break. Yeah.
Our informal poll here of our guest that is going on.
Okay, well, Carl, where can listeners find you online? And is there anything else you want to plug from Optiver? Are you actively recruiting or anything like that?
For me, myself, online, I tend to keep a pretty low profile. I don't even have a Twitter handle. Optiver's always hiring, of course. So I think I forwarded my link, which I guess you guys will add to this podcast. So yeah, Optiver's URL is there. Check it out. Of course, we're always looking for people interested. And yeah, that's about it from me.
Awesome.
Okay. Thanks, Carl.
Thanks.
Great. Thanks, guys. Pleasure.